So here we're going to calculate the second moment of area, or the area moment of inertia. And what the moment of inertia is, it's just simply a measure of how hard it is to either bend or to rotate something, depending on how its shape or how its mass is spread out from a particular axis. And in this instance, what we have our x and y axis located at the very edge of the shape, to the left and at the bottom. And the shapes that we have here, we have a rectangle, a triangle, and a cutout circle. So we're going to have to analyze each of those as individual entities and then summarize our results holistically. So we're going to evaluate the area moment of inertia about the y-axis. So for the rectangle, what that formula will look like, we're going to use Iy to suggest we're going about the y-axis, and that will be equal to 112 and height multiplied by base cubed. So that's one formula we'll need later. For triangle, and it's a right angle triangle as well, so what we're going to use is Iy, and for this one it's 1 over 36, and that's height times base cube. And then finally we're going to use the formula for circle as well, and for the circle again Iy will be equal to pi r to the power of 4 all divided by 4. Now, because we're using our parallel axis theorem, then what we're going to say for the sums is Iy equal to I, and I'll just put that as local, which represents that area moment of inertia for each of those shapes, and that's going to be plus the area times the relative distance to the axis that we're looking at squared. So let's get going, and we're going to start with the first component, which is our rectangle. And as for the rectangle, we have a height of 75 plus 75 there, so that's 150, and our width there is 50 plus 50, which is 100 millimeters. So if we were to evaluate that now, let's start breaking it down step by step. So that's our rectangle. So first we need to find the area, and the area is simply 100 multiplied by 150, and that's going to give us 15,000 meters squared. So we need to find the area moment of inertia, centroid, and what that will look like, just like our formula up top. So that's going to be 1 over 12 multiplied by the height times base cube. So 1 over 12 multiplied by 150 and multiplied by 100 cubed, and that will give us 12.5. I'm just going to use some standard form here, times 10 to the power of 6, that's millimeter, the fourth power. Now, in terms of the distance, so we're going to measure that up to the center of this shape because it's a rectangle. So our distance will be half of that 100. So our centroid would be right there in the very center for the rectangle. So that distance in relation to our y-axis is going to be 50 mil. So all we have to do next is to do our area multiplied by distance squared. So that's our next step. So AD squared. And what we have here, so for the area, what we had was 15,000. So I'm just going to write that as 15 times 10 to the power of 3. And that will be multiplied by the square of our distance, which is 50 squared. So what that looks like, that's now 37.5 times 10 to the power of 6. And that's millimeters to the fourth. So in terms of our sum for Iy now, then what we're going to add up is what we found up top for the centroid. So right here, that 12.5 times 10 to the 6. So we have 12.5 times 10 to the 6. And we now need to sum that. So that's going to be added with our AD squared. So we just add that bit there and multiplied now by our AD squared. So we're adding that AD squared bit now. So that's going to be plus our 37.5 times 10 to the power of 6. And this gives us a grand total of 50 times 10 to the power of 6. So for the triangle, we said that our base, let's have a look, see what this is. So if we just draw a dotted line going all the way down like that, that's going to be representing our height, which is 150 meters. And you can see our base going across there as 75 meters. So that's going to be base 75, height 150. So let's go ahead and do the calculations now for our triangle. So it's going to be more of the same structure. So for the triangle, step 1, let's find the area. And the area of the triangle is half our base times height, so half, multiplied by our 75 multiplied by our 150. And that's going to give us 5,625 meters squared, so 5,625 meters squared. And then if we go down to do the centroid now, so that's I centroid for the triangle, and if you check back the formula that we wrote earlier, then that's 1 over 36 multiplied by height multiplied by base cubed. So let's get that sorted now. So that's 1 over 36 multiplied by our height multiplied by our base cube. So height was 150 and base 75 cubed. And that will give us a massive number. So I'll just show you what that looks like, and we'll convert that into standard form. So 1,757,812.5. But we can just simply write this in standard form and have it written as 1.76 times 10 to the power of 6 meters to the fourth. So now for the distance, and remember this is going to be relative to our y-axis, so let's check that out now. So for the triangle, in the previous video when we did our y bar, our x bar, then x bar and y bar was just the base divided by 3, or height divided by 3 for the y bar. So what we have then, it's going to be at 1/3 of our 75. So that's going to be 25 meters there. And that needs to be added to this 100 meters that's coming across. So that's this 50 meters plus this 50 meters and plus the 1/3 of the 75, which gives us that 25. So our D for the triangle is going to be 125 meters. So that's 125 meters there. And all we have to do next is the rest. So A for area times D squared. And when we do A times D squared, just to put things into perspective, what we're doing is this part of our calculation. So A times D squared, so A is 5,625 multiplied by 1.76 times 10 to the power of 6. And if I'm to put in the exact value, then what we end up with is 89,648,438 meters to the fourth. And I'm going to just rewrite that as 89.65 times 10 to the power of 6. And that's meters to the fourth. So what we need to do, we're just going to sum these totals, and the totals that we sum will be this one and that one there. So what y will give us is 89.65 times 10 to the power of 6. That's meters to the fourth. So the last shape that we have now is one that we will have to subtract because it's a cutout, it's a circle. So let's go ahead and do that now. So for this circle, so what we have here, the radius of the circle, if I recall correctly, is 7 meters. And what we have to do now is to do the exact thing. We're going to find the area, we're going to find the centroid, and this is what we'll use to find the centroid, which is pi r to the power 4 divided by 4. And we find the distance, might as well do that now. It's going all the way up to the center of the circle there, which is going to be 50 meters. So all of that we'll use now. So for the area, we know it's going to be a subtraction, so minus pi r squared, which is going to give us that minus pi times 7 squared, and that equals negative 153.94 meters squared. Then for the I value now, centroid bit, that's going to give us again minus pi r to the power of 4 over 4 times 7 to the power of 4. What we end up with is minus 1885.74. That's meters to the fourth. We did our calculation already for D, and that was 50 meters. So that's the length from our axis. Then we need to do AD squared, negative 153.94 multiplied by 50, and that will give us 384 point, I'll just put 85 times 10 to the power of 3. And our unit is meters to the fourth there. Now what we need to do with all of this is to find our sum, but just before that, let's finish this one to get I. We have minus 1885.74, and that's representing our value there that we found for the centroid, and minus the bit that we just calculated for the area, which is our 384.85 times 10 to the 3, and we get something like negative 386.731 meters to the fourth. So that sums up everything that we need to have. So now all we need to do is to find the grand total for IY. So IY total. So what we end up with, so 50 times 10 to the 6 and added with 89.65 times 10 to the 6. And now we need to subtract this one, which is our 386.731. So just about rounded to give 1.39 times 10 to the 8. And in terms of our unit, of course, it's meters to the fourth. So that's it for this one. And if you found any value, please subscribe to the channel to help us out and like the video.